Well, g'day, Max here again. Welcome back to the shop. So this is the third and final part in the repair episode on our Heron K24 lathe. So I'm just going to give it one big last push and get her up and running. So I think last episode we were doodling around with the compound slide. So let's knock that off first before we move on to the next item. So also last episode we had to deal with this loose handle, so I've turned up a new tapered pin and that's all fitted in there now, and it's tightened up the handle quite nice. So yeah, everything's ready to go, so let's get her on. Bit of Texas tea, plenty on, because yeah, there's no provision for oiling this once it's together. Okay, let's get our gib strip in. Okay, well, we got our gib strip in and adjusted up. The old GoPro did its thing again and cut out. But there is a bit of wear in this. It's not too bad the first couple of inches, but when you get back it starts to tighten up a bit. So we know when we do the overhaul we're going to have to remachine all this. So, all right, well, let's. I'd rather have it a little bit firmer than have the thing flopping around. So I think I'll dig out the tool post next, and we'll make a plan with that. So this is the tool post that we're going to use. It's a Dixon knockoff. And Dixon's, you can tell straight away the machining on a Dixon is very good quality, and all the ones I've seen have a round circular shaped clamp instead of these square ones. So that's just the lock, anti-rotation lock. These just should all come out. They're all pretty dry and gnarly. Little spring, don't lose the springs. Spring. Spring. So yeah, that's all there is to it. Just the cam that pulls the tool post in onto the V grooves, which are here. I really like this style of tool post. It's one of my favourite. Well, it is my favourite because it's the one I've used mostly through my working life. Well, there's nothing else to disassemble on here, so we'll get a soaking in the little washing machine that we got there and see how they come up. This part that we had in yesterday come up quite well, quite happy with it. So we'll get all these bubbling away. We'll have a look in a couple of hours. So the cruddy old tool post parts, let's clean them up very well. Taken most of the rust off them as well. So we've got our tool post parts all cleaned up, come up very well. I don't know where this tool post was made. Yeah, it's a Dixon knockoff. It is what it is, and we're going to use it. It's at least the body's hardened, so that's a good thing. I'm not sure about, I didn't try the rest of the bits, I assume these are. So assembly on these, just got a dab of grease to hold. There's a little spring, a little bit of grease to hold it in situ. These go in as such. Give them a bit of a wiggle, make sure your spring's seated. Make sure we're looking at it in the right orientation. Okay, the cams, these are just a cam to pull these plungers in. Go in, push down, you feel them wiggle into this spot, and it goes like that. A bit. Alright, see how it goes. Next one. That's our tool post assembled up. So our tool block slides on, as you would have seen in probably previous videos, and you rotate this around, clamps it in. There's a tool block here, clamps it in. Okay, let's get this on the machine. So all of the plungers and the cams, I only give a very light coating of grease, and the grease I tend to use, which is my favourite grease, is this Castrol Spherol SY 2022. Reason I think this is the best grease is because I found it. And I do prefer the white coloured grease over the darker blue and that. So okay, let's get this on the lathe. It has this little sleeve which locates it. It's actually a pretty ropey fit. A bit like an old proverbial cock in a shirt sleeve. But it'll do for what we've got to do at the moment. That is, we'll have to machine up a new slug for it and make sure it's a proper fit on the tool post. You don't want this carry on here, but we're not going to be doing any heavy machining with the jobs that we've got, or the one that I have to do. So it's been like this for a long time, so it'll live again like it for a short period of time. When we do the rebuild, we'll attend to all of that. Now I would prefer to have a bronze washer under here, but I've got one somewhere that would do the job, but it's somewhere. Because of our move, everything is everywhere. Okay, give that a good nip down. Okay. So I'll leave that loose, so it's obviously loose. And this is a locator anti-rotation pin, but this compound has never been drilled for it, so we'll just set it in there for now. Another job when we do the rebuild. So when you go over a lathe properly from stem to stern on a rebuild, there's an incredible amount of hours and time goes into an old machine. So anyway, what are we going to look at next? Lead screw support. So due to the length of the lead screws and feed shafts and the clutch shafts, long bed lathes have to have these supports, brackets. So it's a hooked affair. It has bronze liners in it for the lead screw and for the feed shaft, as they're continually rotating in it. So a lot of lathes have two. This one has one. I wouldn't be surprised if if this did come out with two due to the length. The JFMT has two, so these just hook on underneath. Now there's a not sure if that plate is a plate, and that cap screws. Yeah, I think that looks right. Yeah, so they just support the weight of everything. Plus you've got to remember, keep them out of your area of travel, so you just slacken them off, slide them along. So we'll just leave it just in a sort of a bit of a backed off state so we can move it. Right. I've slipped the way wipers off just for a quick inspection. I'm not going to replace them at this stage because the main one at the front here, the housing is broken, so I'll have to machine up a new housing. So this will be done before the rebuild probably. It is quite a critical area just here. So when I machine this one up, I'll put new felts in them all, but I just want to slip them all off just to make sure there's nothing trapped under there that's going to do more. We don't want to be doing anything that's going to create more damage. So I'll just do those off camera. And it's going to be the same as this one. It's just slip it off, have a look, make sure there's no grime, swarf jammed under them, and I'll refit them. It is, I consider it is a very important area, so they need looking after. So that's the way wipers done, as much as I'm going to go with them at this stage, but yeah, at least we've had a good look at them. I've just pulled off, this is the rear keeper. What this does is it stops the rear of the saddle lifting up, so it mounts in place under here. So I just want to make sure we're not full of too much crap under here that's going to give us problems. These are adjustable too. There's grub screws underneath them, so you can adjust the clearance that it runs in, because they do run in just slight clearance underneath the bed. They just stop the whole show from being able to lift up. There's one under the front too. I'm pretty sure these are the two of the mounting screws. And there's two more over here as well. Generally that front one you can't get off without dropping the apron, but I might just have a look at that one. So I'll get this cleaned up and refitted. So that's that rear keeper back installed. Let me show you something. When they're in proper adjustment, remember in the first video how tight I couldn't wind the carriage back here? Well, this is effortless. This is feels like a brand new machine. So easy. That's how it should be. Let me show you how I adjust it. So underneath you have your series of clamp bolts, and in between them we've got these adjuster bolts on this one. So what I do is back the adjusters all the way off, just very lightly nip up the clamp bolts to bring the strip up hard home, and then I'll screw in the clamp bolts till they make contact. Then I'll back the clamp bolts out half a turn, then I'll screw in the adjuster bolts back in quarter of a turn, and then very just lightly nip the clamp bolts. And I'll go back and try it. If it's too tight, I'll come back, slacken the clamp bolts off and go another quarter of a turn on the adjuster bolts until I get free movement of the travel. Bear in mind too, you don't want this tight, but you don't want it too loose either. You want it as tight as it can be, still have free travel, and not actually be contacting the bed underneath. So yeah, that underside of the bed is a very critical area. You've got to make sure you keep the oil up to that yourself. So that's actually used too when the beds are really rooted. You can use this, providing it's not knackered, as a reference area if you have to remachine the bed. And there's nothing, no good reference areas on the top to pick up off. This is a really valuable spot to have to use. So the front keepers on this lathe are just two little short ones. They're not the full one-piece one that goes along as some lathes have. So I was able to get them out, clean them up, so we'll get this one back installed. This one also is part of the carriage lock, so this screw pulls up. It actually, there's a flexure joint there, and it actually flexes this part here up, and that is the carriage lock. So hopefully we can get this in without getting ourselves into too much trouble. Bit of dirt in there. Too much trouble, I mean, as in the thing escaping from my fingers and falling in some place that I can't get to. Now we're away. So I'll just squirt a bit of oil up into that. I didn't want to pre-oil it and get it all over me fingers. It runs in clearance underneath anyway, so it's just stops the front of the whole carriage assembly being able to lift up. That's it. And of course our carriage lock. Leave that loose. Right, the front one will be the same, so I'll do the front one off camera. Well, I thought the front one would be the same. The head of the cap screws actually snapped off, and it was just sort of sitting in the hole. So we've got no option but to leave this one well alone, as to we'd have to try and drill and maybe get that out with an easy out, or wait till we strip the lathe and deal with it then. So I think we'll wait till we strip the lathe and deal with it then, as the its other screw is still holding it in position. So we'll let that one go. Okay, so we have the lid off and everything looks to be as it should be in here. The gears, they're all in good condition. Doesn't appear to be any hidden surprises. So we'll see how it runs. What I'll do is I'll just change the oil on this and see how it goes. Decent sized gears, as it should be for a machine this size. This is its speed chart from 12 up to 1200 RPM, so it has a reasonable speed range. Massive range of pitches and threads per inch this thing can cut. This thing will blow your mind when you can see what it can do. 80mm pitch screw thread. So the rear gear set's just a pretty standard affair. Nothing really to do here, just make sure they take a bit of oil every now and then. I have already adjusted this up. I did it off camera the other day. It was just a matter of adjusting the lower gear backlash back into the center one, and then move the whole banjo across to get our backlash correct in here. So the belts are all good enough. That's the drain for the headstock oil. We'll drop that out shortly. Clutch, it's been welded there. I don't know, something funky going on there, but must still be hanging in. What I do need to do is make sure that we can actually get some oil into these two shafts. Interesting, it's got the C-shaped retainers, same as the JFMT lathe has. I'll pop one off. Yeah, same as the JFMT. Just a bronze bearing. Shaft's not too bad, could do with a little polish up. Let's see if we can get oil into them. That would be a no. I actually replaced these with oil nipples on the JFMT, and I think we'll do the same on here. So I'll just manually oil them for today. Yeah, this is something we're going to have to attend to. Not a fan of these horseshoe clips. At all. Yeah, do the same. I can see, yeah, the oil ports are blocked. I can see it. Yeah, so we'll get rid of these ball oilers. We'll have to pull the shafts out, put them in the lathe, and we'll drill and tap them for grease nipples. Then I can use my oil gun on them. Okay, it's all good in there. And put the cover back on. Okay, let's drain our headstock oil. See what sort of hidden surprises we get here. Black like engine oil. So let that drain. Who knows what sort of oil that is, but it's not supposed to be that colour. That'll take a fair while to drain. Right, so the nose of the spindle on this lathe is an L2 taper, or American long nose. So it has this big retainer nut that draws the chuck in onto a taper. Normally you have a big C-spanner, you whack with a hammer to get these nuts loosened off. I've just got a big brass drift, which we'll try at the moment and see how it goes. I'll just sit you out the way. Well, I just had to go and quickly swap oil drums. It's just the dregs coming out now. So I'll let that continue. So that's 20 litres already out of it. So we'll see how much more comes out. So we had to change tooling with our chuck removal. I was going with this brass drift and this copper hammer, but had to switch to this 14-pound adjuster here and our brass drift. That nut was tight. I think I've just cracked it, so let's set you back up in the stand. Just got it. Switch over. So the nut comes loose now, and then the nut will get tight, and that's the nut then forcing the chuck off the taper. That's it. So I just use wood here so I'm not beating up on the headstock gears with the machine in low gear, being how tight this thing was. Okay, let's get the hoist set up on the crane, because it's a bit heavy for me to manhandle. This is a good quality Pratt Bernard 3-jaw chuck too. Like, there's no side play in the jaws. The wiggle feels quite good. There's a little bit of end play, you get that, but side wiggle, she feels pretty good. So all right, I'll get a sling around this and we'll get her taken off. There is a bit of a trick to these L2 tapers with regards to refitment and removal. We'll get this one off and we'll show you what it is. Oh, she's stuck. So there's something going on, something funky going on, because this nut should have ejected this off the taper, and it hasn't. Now it is. Okay. Rust. Thankfully not on the important part. Yeah, a bit of corrosion going on there. There's the nose. So that's the taper there. And this nut pulls up and pulls the chuck onto the taper, and this keyway drives it. So the secret with these things, when you take your chuck on and off, you should have your, well, I would normally have a chuck marked. This keyway, if it's not on the 12 o'clock position, makes it a real hassle to get the chuck mainly on. Off's not too bad, but unless that's at 12 o'clock, yeah, it's a bit of a hassle to get on. So hopefully we'll get away with just a bit of a clean up here. So it just appears to be staining, and so I'll get that cleaned up and then have a look why this nut didn't eject the chuck off the taper as it should do. Well, that's cleaned up as good as I can get it for now. I'm pretty confident the taper will still be fine. Yeah, took me ages to clean this thread out, the rust out of the thread, but we got it now. As to why the nut's not ejecting properly, I don't know what's gone on in here, because you've got to actually remove the spindle to get good access to these nuts. The lathe I used to run had the same nose, and yeah, once you cracked off the initial torque holding the chuck on, you'd only go back quarter of a turn or whatever, can't remember what it was now, and the nut would tighten up again and eject the chuck off the taper. So we're ready for our chuck. So this will be the chuck we're going to put on. Back in its day it was a really good quality chuck. Now it's a slightly beaten up old chuck with a corner missing out of it. It's a Pratt Bernard. Needs a lot of attention, but it'll do what we need it to for now. When yeah, the old story, when we overhaul the lathe, we'll overhaul the chuck. So let's get it mounted up. One other point which I got a bit of a chuckle out of is this drain tray here. It comes down into a hose, into an oil bottle. So yeah, we don't know what's gone on for the seal. It should just be a straight labyrinth seal. So yeah, we're not sure. I mean, it's been messed with before. There's butcher marks on the ring here, and further in the headstock you can see where the yeah, there's butcher marks on the flats on the nuts. So we've got our fingers crossed. And our oil drain caper nearly turned into a bloody disaster. So yeah, we'd filled up the 20 litre full, and it was still a bit dribbling out, so I grabbed this one here. It's a 4 litre container. And when I went to bed last night, it was probably a third full, and the oil was only just barely dripping out of the pipe there. So when I come back in this morning, she was chockers. It was just lucky that the funnel was a tight fit in the bottle, and yeah, so a little bit of overflow there. Nothing on the floor, so we had a win. Okay, let's get this chuck on. Keyway, 12 o'clock. And our keyway here is at 12 o'clock. Okay, I'll give this a bit of a tock up. I'll put the chuck jaws in first so we can lock the chuck from turning. Alright, let's get our jaws in. Bit of wear in it, but still got a lot of life left in it. Oh, chuck wrench is a bit cheesy. We'll have to, we'll keep that part and we'll make a new cross piece for it. It's on a bit longer. Number 3. Number 4. And we did spare you an hour-long episode of cleaning a 4-jaw chuck in 400 litres or 2 or 3 grand's worth of evaporust. Okay, I'll just get this chocked up. We'll just give our lock nut a bit of a tock up. I am giving this a little bit more than normal, just because of the state of the thing. Okay, that should do it. Okay, normally a big C-spanner doing them up. It's a big hammer like this. couple of good whacks, and that's good enough. Always with the machine in neutral, so we don't do any damage inside with the gears. Okay, what's next? I think we're just about there. Might have to put some oil in the headstock, and just about ready to crank it up. Right, time for some oil. So I mopped out what I could of the black sludgy crap that was down the bottom. So rather than put the standard headstock oil in, which would be 46 or 68, I'm going to go with the flushing oil. As it's so gungy in there. Automatic transmission fluid. So we drained 25 litres out. And we'll run this for a short time, then we'll drop it out. Okay, there's 20. Not on our sight glass yet. There it is there. Okay, on with its lid. I can't run the machine with the, well, I could on a slow speed with the lid off, but it doesn't have like the row of oil distributors in the top like some machines do, so you can check to make sure you're getting oil flow everywhere. I think it'll be alright. Okay, moment of truth. So try our power feeds, longitudinal, that's working, cross feed's working, that's for the half nuts, but we need to clean the lead screw first. I'll put something in the chuck to stop it clattering. That's a win. Right, we've got a piece of bar in the chucks. I think that's about 100 mil, 110 mil, just black bar. Gonna have to get some bigger tools for this lathe. This is one that we use off the other lathe. She's only just getting in there, and so I've had to sit the tool holder up above where it normally sits. So anyway, let's run through some of these speeds and we'll see how we'll see how it's running in some of the gears. So I'll start off 12 RPMs. Good slow speed. Okay, so 16. Not much difference. 22. So 30. 42. Sorry, that was 55. 42. Yeah, that's 42. 55. 80. And 105. Uh, 140. And 190. Should be 350. Uh, 480. $6.50. Okay, that should be. A bit confusing on this dial for the speeds. Okay, we've got 900 and 1200, but I want to run the machine a bit longer before I take it to its higher speeds. So we'll drop it back, say 350. We'll try a cut. I've already set our feeds on 16 thou, so we'll just take 100 thou depth of cut and see what happens. Just check that feed, because yeah, it didn't like 100. 50 was alright, but that was quite a rapid feed. Let me just check, see what this feeds are set at. I thought I had it set on 16, but it seemed pretty rapid. Just drop that feed back to 11th hour. That's 100 thou there, so that's 200 thou off the diameter. Well, there's its first chips. So I don't want to push this too hard. They were 100 thou off the 100 thou in feed, so that's 200 thou for diameter. And like, it is a small tool. I'm only properly clamped in with 2 screws. So I don't want to push it too hard. So we'll let the machine sort of settle in. And see how it goes, but yeah, she's alive. Just as a matter of interest, I mic'd this up after those roughing cuts, and there was a 3 thou taper there, so I'm going to take a 20 thou finish cut. It's on a 5 thou feed rate, and we'll just see if our taper goes away. Incidentally too, I said this was mild steel. I don't think it is. I've got no idea what it is. It's just out of my scrap pile. I don't think it's mild steel. It could even be 4140, or it could be anything. I've no idea what it is. So let's just take a 20 thou cleanup cut on the 5 thou feed rate, and we'll see if our taper changes. Still on the 350 RPM. Actually, we might bring it up. Probably we'll go for 480. This definitely ain't no mild steel. That's within half a thou. Yeah. So that's pretty good considering the wear on this machine on the bed. Yeah. She's some sort of good quality scraptonium, this stuff here. Well, I think we'll bring this one to a close here. We've achieved our desired result. That was to get this machine up and running. So I don't want to push it too hard at the moment. I don't want to bring it up to its final speeds until it's run for a while. Plus the machine still has to be leveled and we still have a lot of work to do to it, but in a pinch it's a usable machine. So hey, it was a bit of a big rush to get it going because I do have that job I have to do the screw thread on, so I'll have to clean up the lead screw and check to make sure it cuts the thread okay, and we'll see what happens. Anyway, cheers, thanks for watching, and see you next time.